So in our second design pattern video, I decided to split them up because I realised we're going for about 10 minutes in the other one. So I suddenly thought I'll just do this as two separate videos because it'll be far easier for you guys to digest. I'm going to give you an overview of what we call game design patterns. So many of these are really useful to help with complex coding structures, in particular in games. There is a book called Games Programming Patterns. I'm giving you a URL there. It is free on the internet, so you can get it at that URL. Remember that in your game, you must implement an architectural design pattern, such as the model view controller or the entity component system. So that's a design pattern that governs the whole architecture of your class diagram, all the classes together. You must also use two other patterns, and they can either be design patterns or game patterns. So what I'm going to do is give you a very brief overview of each of the patterns in the games programming book, so you can think, okay, I might be interested in that one, I'll go and find out more about it. So this is just to whet your appetite, really. I'm starting with traditional patterns. So these are patterns which are all over 20 years old, but are still really important, especially to games. So these are really your traditional design patterns as opposed to games patterns. So hopefully, last year when you learned C++ and C, you might have heard something like a callback, which is where a function really calls itself. The object-oriented version of callback is the command design pattern. What I really mean is it's a method call wrapped within an object. So it's a way to take a method call and put it within an object. Okay. The flyweight design pattern comes into play when you have objects that need to be more lightweight. Generally because you have too many of them. And just having so many objects around is really making your system run very, very slowly. It's often used in games to cut down the size of background models. So for example, if you've got lots of foliage, lots of trees, then you can use the flyweight pattern to cut down the amount of size that takes to store and the speed it generates. The observer lets one piece of code announce something that interesting happened without actually caring who receives the notification. So this is often used for things like achievement systems. Imagine that you've got lots of achievements in your game and you're doing a game about, I don't know, Billy Goat Gruff, and you've got an achievement for crossing the bridge 10 times. Well, you don't want to hard code those achievements into your bridge code. Otherwise, you've got that code there that doesn't really fit at all with that class, and so you've got a lack of cohesion. Okay, so instead, you might want an observer there that will tell the achievement class every time the bridge is crossed, and that's how you operate that system. The prototype is the next one. The key idea is that an object can spawn other objects similar to itself. For example, if you have one ghost, you can make more ghosts from it. So you don't define it once and it can make more of itself. If you have a demon, you can make other demons, and so forth. So basically it allows you to treat something as a prototype and use it to generate other versions of itself. The singleton ensures a class has one instance and provides a global point of accessing it. This is often used in games. I'd be quite careful as it does create a global variable which is not very concurrency friendly, and as we've said, most games nowadays are implemented in a concurrent way. The state gives you the state within an object, so it can be standing, jumping, things like that. We saw that one today in the book. Then you've got what we call a sequencing pattern. So these are into our new games patterns now that are really created for games programming. So double buffer, we saw this in the chapter on implementing graphics. It makes sure that the scene does not change during drawing. That's its main purpose. The game loop, again we've seen this already. It's the thing that runs once per frame, takes the input, updates the game state and does the output. With the update method, that's part of the game loop, but it's a bit that actually does the updating in the game loop. Okay. Next we've got behavioural patterns. Bytecode is an instruction set which defines the lower level operations that can be performed. It's a series of instructions encoded by a sequence of bytes. A virtual machine then executes these instructions one at a time using a stack for intermediate values. To be quite honest, this one is quite complex, quite low level, because it's talking about the byte level, and I don't think you'll need it for this module. The subclass sandbox is a base class defined as an abstract sandbox method and provides several operations. If you mark them as protected, it makes clear that they're used for a derived class, and each derived sandbox class implements the sandbox method using the provided operations. Again, this is really one for working in large teams because it allows you to say, okay, you've only got access to this and this is all that you're allowed to do within that class, so probably not particularly useful for this module. Type object allows the flexible creation of new classes by creating a single class, each instance of which represents a different type of object. This is really useful when you want to be able to modify or add new types of new non-player characters without having to recompile or change the code. So type object is the one that you really should look at for this module. Then we've got what we call our decoupling patterns. We've got the component, where a single entity spans multiple domains. To keep the domains isolated, the code for each is placed in its own component class. The entity is then reduced to a simple container of components. For example, you might use this if a class is getting massive and hard to work with and you need some way to deconstruct it. So often actually the player class is a really good one to look at in regards to the component. The event queue is a queue which stores a series of notifications or requests in first in, first out. And it allows you to think of the order that you're going to process events. Okay. The service locator provides a global point of access to a service without coupling users to the concrete class it implements. Use this one quite sparingly as it can overly complicate things. Instead of using a global mechanism like this to give some code access to objects if it needs, first consider if you could just pass that object. Okay, that's easy and it makes the coupling completely obvious. And actually for this model, that should cover most of your needs. So you probably will not need a service locator. Last but not least, we've got the optimization patterns. So data locality is about where you actually store data within the program. It accelerates memory access by arranging data to take advantage of CPU caching. Modern CPUs all have caches to speed up memory access. These can access memory adjacent to recently accessed memory much quicker. So it takes advantage of that to improve performance by increasing the data locality, keeping them together, and it can be quite useful if you're finding everything to run a bit slowly. The dirty flag avoids unnecessary work by deferring it until the result is actually needed. So it says, okay, I don't need this bit of work at the moment, except we've already calculated it elsewhere, and so therefore I can just use that result until I need to calculate a new one, until something's changed that requires me to change this bit of data. Okay. In your games, you're again unlikely to need that level of optimization, but I thought I'd mention it because it's the sort of thing that can come into play again if you feel that you're running a bit slowly, if your frame rate is getting slow, if there's other issues of that type. Object pool improves performance of memory usage by reusing objects from a fixed pool instead of allocating and free them individually. So it means you don't have to do so much garbage collection within your game. Again, that one might be useful if you're not running to speed. And then last but not least, we've got spatial partition, which efficiently locates objects by storing them in a data structure organised by their position. For a set of objects, each has a position in space, and you store them in a very spatial-based data structure that organises objects by their position. So it allows you to really efficiently query for objects and say, is this near this? Is it far away from this? It's particularly useful if you're going to implement something like a radar system. Okay, that's everything. I hope that was useful for you, and I will see you on Monday.